Hello, everyone. Welcome to the webinar on how to automate application security and keep up with modern continuous integration, continuous deployment. I'm Priya Chawla, Director of Product Management at ShiftLeft, and I have with me Ethan Lightstone, who's our VP of Product Design.
Good morning.
Great. So in this webinar, basically the agenda is we'll cover the characteristics or the elements of a modern CI/CD process and look at traditional security approaches that we have been using historically. As we understand those approaches, we'll identify the challenges that traditional security has in a modern CI/CD process, identify the application security requirements in this new world, and what are the approaches to automating security with respect to these requirements. After that, Ethan is going to give us a demo of ShiftLeft product, and we'll answer any questions. Feel free to post your questions in the chat window, and we'll get to them towards the end. So what do we mean by a modern CI/CD process? Essentially, automation is the fundamental part of the CI/CD process. And when we talk of automation, basically CI, which is continuous integration, is about testing automation and making sure that your application is not broken by any new changes or commits to the main branch, right? A continuous delivery process means not only you have automated your test, but you've also automated your release delivery process. So you can deploy your app at any point of time by clicking a button. And essentially, continuous deploy is being able to release a change as it passes all stages of your production pipeline to your customers at any time. Agile development, basically being able to iterate faster and developers being able to focus on building new software and new changes. Being able to build faster and fail faster. Ultimately, the developer changes have to be validated by creating a build and running automated tests against that build. And so we can avoid the integration hell that typically happens when people wait till the last minute to merge changes into a release branch. So basically being able to capture bugs earlier through regressions by running automated tests. And being able to leverage a hybrid environment and get the best of all the worlds that the cloud has to offer. So historically, we protected our data center using a defense in-depth strategy consisting of a firewall, a web application firewall, an intrusion detection or intrusion prevention system. And basically, all these approaches have inherently not focused on the application itself. They treat the application as a black box and try to protect this application from the outside in approach. We do vulnerability assessment, and so we can patch and protect, but the inherent assumption in all these approaches is reacting to threats. So you're codifying threats into signatures to protect your application. How does the security or the traditional security approaches, what are the challenges of this approach in the modern CI/CD process? As the release cycles have shrunk, so we've gone down from releasing a few times a year to several times a week, or sometimes several times a day, as Netflix does. Basically, being able to release at any point in time has become a key characteristic. And because most of the security solutions take long time and their run times are long, basically it's harder to enforce security in a faster release cycle environment. As we've moved from monolithic to microservices architectures, again, security has become complex because now you have to protect every single microservice against its specific attack surface. And notice that the service interactions of microservices are not local anymore, right? They're remote, mostly over HTTP. So essentially being able to track the flow of data across a complex web of microservices has become challenging. And as we have moved to cloud, it has forced our organizations to re-architect how they do security. Because as organizations, you're no longer responsible for the security of the network or the server. All your focus has to be on one thing that you own now, which is essentially your application or microservice. So these are the challenges in a modern world that a new solution need to address. So what are the 6 modern application security requirements? And we'll go into the details of each of these in the next slides. The first one is being able to protect all aspects of your code, right? And essentially, code is now a more increasingly being assembled rather than developed from scratch. Being able to provide comprehensive protection against all vulnerabilities in production, and we'll define what we mean by all. Being able to be much more precise so you can give quality and actionable feedback to your developers. Having the security being automated and integrated into the CI/CD workflows. Having a low production overhead. The last thing you want is to have a poor user experience. So this is one of the critical requirements of a modern solution. And the last but not the least is continuous, which means not only is your testing and your release process continuous, but your security is continuous as well. So you can actually embed continuous improvement in your development lifecycle. So protect all aspects of your code. Today, your code essentially consists of your custom code, open source libraries that you're using, and third-party libraries you're using. So as an owner of an application, you're really responsible for security of all components within your microservice. So it's not only known vulnerabilities in your code, but it's also understanding the vulnerabilities in the open source software and how your microservices are interacting with those open source libraries or third-party libraries, so you can identify any vulnerabilities that could arise out of those interactions. Comprehensive production security. So what does comprehensive really mean? We know what known vulnerabilities are. CVEs and NVDs have been around for a long time. Basically, again, the problem around known vulnerabilities is that limited time and resources, which means your dev team may have some knowledge about certain weaknesses in the code, but it's not possible for any human team to be aware of all known vulnerabilities in your code. And there could be several hundreds of these known vulnerabilities. 0 day in your source code. So we talked about how today's code is really an amalgamation of your code and third-party or open source code you're using. So if an exploit happens, it really doesn't matter what component of your microservice gets exploited. It could be an open source component, it could be your custom code, or it could be how these various components are interacting. So you're not only responsible for known vulnerabilities in open source, you're also responsible for unknown vulnerabilities in an open source or in a third-party library that an unsuspected developer could have used improperly. And notice that you not only need to do this for once a week or once a month, you need to do this for every version of your every microservice. And so if you're releasing multiple times a day, and if you have several of these microservices, this problem only gets compounded. And so comprehensive production security really means addressing 0-day vulnerabilities in all components of your application for every release of your every microservice. Precise. We've all heard of alert exhaustion, several false positives. So the goal is really to be able to give quality feedback to developers. If you've identified 100 vulnerabilities in a piece of code and go back to your development team to fix those, they're much less likely or incentivized to fix all 100. But if you go back to your development team with the list of 10 prioritized issues based on some real runtime data that they should fix, they're more likely to fix it. So ultimately, the key in any security solution is being able to be precise and deterministic. And this can only happen when there's a continuous loop and feedback between dev and production. Automated. Automation is fundamental to CI/CD. So the integration of security into automated CI/CD processes is necessary to make it easier and faster to develop and deliver secure software. And when it comes to automation, it essentially means being able to understand your code as it evolves, being able to provide this feedback automatically to your developers, and being able to evolve with your application or microservice as that evolves. Low production overhead. The goals we talked about earlier around comprehensive protection, about understanding, protecting all aspects of your code, about automation, they are great. But if you experience from a poor user experience or your service completely comes to a halt, it's not worth it. So ultimately, you need a security solution that does not add latency, does not add memory, impact overhead to your application in production environment. So you want to keep the footprint of the overhead as minimal as possible with respect to all of these. And the last but not the least, again, is continuous. And so just like we've established this process of continuous testing and automated testing so we can release faster, we want to be able to establish this loop of continuous improvement. So taking feedback from your production back to your development and being able to take input from your development or your code to production is key to establishing a solution that's precise, that adds low minimal overhead, and protects all aspects of your code. So what are the approaches that we can consider for meeting these requirements? The first approach is source code analysis, which has been there for a long time. And we look at how does source code analysis compare across all these requirements. The second is the threat reactive, which is essentially a WAF or a web application firewall or a runtime application self-protection solution. And the third approach that we're going to introduce is the microservice specific approach. So understanding the specific attack surface of your microservice and creating a security that is specific to that version of that microservice. So as new versions involve, your security evolves with it. So let's look at static source code analysis. When it comes to protecting all aspects of code, static source code analysis is great for understanding your code, but where it is essentially weak is data flows. And data flow is the holy grail of all security analysis. Most interesting injection problems could be revealed only with a strong data flow engine. And so understanding the sensitive data exposure of your application, which means being able to identify what sensitive data your application is handling, how does that flow through your application, and ultimately how does this flow from one microservice to the other, is critical to be able to protect your code fully. And that's where source code analysis falls short of. Comprehensive protection in production. Again, source code analysis is primarily understanding your code. There is absolutely no connection to the runtime or the production environment. So you don't really get comprehensive protection in production especially from zero-day or unknown vulnerabilities. Being able to be precise, and that's one of the things where we suffer a lot from source code analysis. Over 80% of the solutions suffer from false positives. Again, because we don't have this feedback from production, that's what is a missing link to be able to make source code analysis precise. It's a manual process. It's really not integrated into your CI/CD pipeline. There is no feedback between dev and production. but again, the overhead is low. So in terms of how does it compare against the requirement, it falls short when it comes to the modern application security requirements. Let's look at web application firewall and runtime application self-protection. These solutions inherently treat the application as a black box, right? So there is no understanding of the source code. The way RASP typically works is it relies on your test suite to model the behavior of your application. So the effectiveness of RASP is as good as the effectiveness of your test harness. And if you're updating your application or microservice every other day, RASP is likely to fall short when it comes to modeling your application well, because you can only keep up your test suite with that frequency of release. So it falls short on the first requirement, comprehensive protection in production. This is great for CVEs because, again, they're based on modeling or codifying threats into signatures. These are outside-in approaches, or modeling the behavior of an application based on the test harness. This approach, the CVE or the threat-based approach, or relying on your test suite or a QA environment, leads to a higher number of false positives. It requires significant manual tuning because, again, one of the challenges of the existing security solutions in being able to tune them constantly for new threats as they come out. And if there are 100,000 pieces of new threats coming out every single day, the manual tuning is only going to go exponentially higher. And it's as good as your test suite is. There is no feedback between dev and production because, again, RASP only operates in a production environment. So there is no feedback from either back to a dev environment or from a dev to a production environment. WAF basically doesn't add much overhead to your application, but RASP, because of the way it works, which is and the way it instruments your application, it adds significant overhead. And that's one of the things that Gartner has highlighted in their recent papers, is the reason RASP is not taking off is because of the significant overhead that it adds to an application, and because of the insertion complexity associated with it. So most of us may have heard of WAF and RASP, but microservice specific is something that may need more explaining. So let's talk about what do we mean by a microservice specific security approach. So essentially, the first element of this approach is you have a plugin or you have an integration that ties into your build environment. So every time a new build is triggered, it conducts modern code analysis on that. And notice that the only way this can be fast and work with your release cycles if the code analysis itself doesn't take that very long, which is one of the problems that has been, problem with the traditional code analysis tools. So you really need the code analysis itself to be as fast as a few minutes, if not, few seconds. Once we have the results of the code analysis, we create the security DNA or security posture of your application, which essentially is nothing but identifying the attack surface of your application and creating a policy that can inform a runtime micro agent that's running with your application in the production environment as to what paths or what parts of the code to observe for at runtime. And so security DNA essentially consists of identifying data, classifying data in your application, so what sensitive data your application is handling, understanding the entire structure of your application, which means understanding libraries, components, frameworks, so you can basically stitch together the interactions between their various components and identify any contextual vulnerabilities, and being able to understand the sources and sinks of your application. So once we've identified the security DNA and we've created policy for our runtime micro agent, we know precisely what issues in your application need to be fixed. So when you go back to developers, you don't go back to them with 100 issues, you go back to them with a list of 10 prioritized issues that they need to be fixed because those 10 are the ones that have been causing or have manifestations at runtime or production environment. So let's see, how does microservice-specific approach compare against these requirements? Protecting all aspects of your code certainly understands your code from the depth, which is understanding your code, the dependencies and the structure of your application, understanding flow of data, and what sensitive data your application is handling. It protects your application against known vulnerabilities or the CVEs, OWASP top 10, and it protects it against data leakage. Because now we've classified and we've identified sensitive data, we understand sensitive data flows, we can clearly protect it, data leakage with extreme precision. It's tied into your CI/CD pipeline, so there is no human intervention and there is no manual tuning, which means every time a build is triggered, this approach or the solution should be triggered basically to identify the attack surface of your application, being able to use that knowledge to inform the agent what to observe for at runtime, and being able to feed that prioritization back to development. So essentially, this gives us a continuous improvement process, which is dev informs production and production informs development. Because this method or this approach is extremely precise in instrumenting your application, because again, we're not instrumenting. The goal is not to instrument your application in all areas. Essentially, only instrument parts of your code which are deemed sensitive or vulnerable. This leads to a minimal performance overhead, and that's the challenges that a runtime solution would typically suffer from, which this approach should solve for. So let's look at how we do this at ShiftLeft. So at ShiftLeft, our vision and our goal is to be able to provide you security for every release or every version of your microservice. And the way we do this is we have a CI plugin that ties into your build environment. So whether you're using Jenkins or Travis or Circle CI or any of the CI tools, basically we are a post-build step. So our plugin gets triggered, and then we understand your application and all its dependencies and frameworks. We extract the attack surface of your application to create the security DNA. Once we've created the security DNA, we inform the runtime agent with a policy as to what to observe for, and we get runtime telemetry and metrics from this agent. And so what you see in the middle, which is our SaaS dashboard, which we'll walk you through in the demo, is essentially a mix of insights from code analysis reinforced by runtime data. And basically, the objective is to be able to enable collaboration between development, DevOps, and security personas. And because we have this continuous loop, that's how we enable collaboration. And the combination of code understanding and runtime data means we can actually take you back to so we identify an issue in runtime, we can point you exactly in code where that problem is, so your developers can remediate and fix it much easier and quicker. So with that, I'd like to hand off the torch to Ethan to walk us through the demo.
Sounds good. Let me just steal presentation mode from you. Perfect. Show my screen. Cool. We're all set. Great. Well, thank you, Priya. That was a great overview. And so right now what I'm going to do is walk you through our product experience, and I'll target a specific use case that I can show you here. And as I do that, I'll walk you through several of the UI elements, which will be a good way to familiarize with how we approach analysis and runtime monitoring of security. So right now I've just logged in, and we're looking at the ShiftLeft dashboard, which will show an overview of all applications that we're monitoring and analyzing. And in particular, I'm going to focus on this one called Hello ShiftLeft, which is a test app that's currently undergoing several red violations or a red alert. And I'll click right into this. But as I go through this, I just want to kind of point out that all of the experience that you're going to see is really a blend of the two insertion points that Priya had described. So code analysis and runtime monitoring are effectively blended together to give you sort of a holistic security visual of the application. So I'm going to go into Hello ShiftLeft. And the first thing you'll see is this is the AppSummary Dashboard for this application. And the first thing up here is a application throughput chart where we're taking calls per minute for this application and plotting it over the last hour. And you can see here that when the app was deployed, these two red lines appear, which indicate violations were detected. So I'll go through one of them, but some of these violations are vulnerabilities or sensitive data exposures that we picked up from the code analysis, but these can also be violations that we detect at runtime. So if you look at this violations group by OWASP widget in the middle, what you'll see is we summarize all the violations that we detect by these standard categories like cross-site scripting, injection vulnerabilities, and sensitive data leaks. And what you'll see is there's this code column. And so if you look at sensitive data exposure as an example, we see 156 discrete locations in the code where a data leak is possible. But then at runtime, we see 81 occurrences of that data leak happening in runtime for real. So this is probably something that we should focus on right away. On the left-hand side of this dashboard, we have what we're calling the triggers of the application. So these are web routes typically for a web application, but effectively for any kind of app or microservice, triggers represent the code that causes data flows to happen or logic flow to happen in the application. On the right-hand side, we have data destinations. So this shows how different categories of sensitive data leak out to different data sinks. So in this case, we have several types of data going out to log, some going out to HTTP, so back to the web perhaps, and some going directly to a file, as an example. So what I'm going to show you is one of the data leak violations. In this case, I'm going to click on payment data and drill in. And anything you interact with on the screen typically just filters the screen so you can narrow down on the problem. So after I've clicked on payment data, what we can see right away over here on the data destination side is individual Java variables that we see leaking out to log. And most of them are undergoing a red violation alert. And on the left-hand side, we see the triggers that are implicated, or in this case, the web routes that are implicated in these data leaks. So one of the things I might do as an operations person is figure out what I can do right away to mitigate this leak, and then I would probably then involve developers to go solve the problem at the code level. And I'll show you how that might work. So if I click on one of these variables, in this case, account number, which shouldn't be going to a log file, we get to a new level of depth here where we can see the actual data flow trace of that sensitive data going out to the log system. So this, I'll walk you through this interface here. So what we can see is the data type is an account model, and it was triggered by a particular class method, which is likely associated with that web route. And then the variable is initialized as a parameter and gets passed from method to method until it reaches the logging system and goes out to the log file. And for me, this is a particularly exciting use case because, as we know, there are vulnerabilities that hackers can leverage in your application, but a lot of the really expensive security problems that organizations deal with have nothing to do with being attacked, but very often we accidentally leave code in, perhaps debug code that makes its way into production, and this can cause a data leak to happen. And it's very difficult to detect. The other thing I want to point out is how we identify this kind of data. One of the differences between typical solutions and what we're doing here is when we I'll click on payment data again. When we attempt to classify data, we don't inspect the data in transit. So we're not like looking inside of variables at runtime to determine, oh, this might be a credit card number, which can have a high rate of false positives. But what we do is while analyzing the control flow of the application, so when we're looking at data flows at the source code level, we look at the names of the variables themselves, and we use a natural language processor to attempt to automatically categorize it. So we saw something named account number as a variable, and we automatically catalog that as payment data. And this is driven by a default policy system. So this can always be fine-tuned if there are, strange variable names that we were unable to detect. Then what you can do is adapt the policy to include that variable and catalog it manually as whatever you want, PII or sensitive purchase data, and so on. So that's the sort of use case in depth. Another thing I'd like to point out is, who are the end users of this experience? So this is a pretty interesting problem. I feel that in modern day security, it's sometimes difficult for the security engineers, DevOps, and developers to collaborate effectively when dealing with security issues. And this attempts to sort of bridge those gaps. So what we have here at this dashboard level, or even higher up, is a very operational lens into the security health of these applications. But we can, identify a problem, triage it, and then finally get to a level of depth, which I'll show you again here, where you get down to lines of code that you could cut and paste into a Jira ticket and hand over to the development team to go resolve. So that's a pretty exciting reality of this product experience. The other thing I want to point out is there's an alerting system, which you might expect in a solution like this. So if you go to the bell icon, another way to go to the alerting system is through this little indicator next to the title of the page, which shows that this application is currently undergoing an alert. But you can effectively monitor your entire infrastructure this way, depending on what your preferred lens into the system is, and look at any ongoing alerts and explore the violations directly. So if I've clicked into a single alert, this alert bucketed several violations together. Many of them were sensitive data leaks, it seems. And the rationale for this is, perhaps at deployment time, dozens of data leaks were identified, and to avoid alert exhaustion, they're all bundled together into an alert, and then you can triage these individually. So if I click into a particular violation, we get sort of a familiar interface here. So we do see the data flow for this particular data leak, and you'll be able to take actions on this or forward it to individuals who would then go, perhaps solve this problem at the code level and then create a new release. So I think that concludes the demo. I'm gonna leave this screen open for now, but just sort of pass the proverbial microphone back to Priya, and I think we'll be doing questions and answers now, right?
Great, thanks, Ethan. So we have a few questions here. The first question is, how does ShiftLeft generate security DNA? So the way we do security DNA is we basically analyze your application and we create a graphical representation of your application. And the reason we do that is because once you've created a graph of your code, it helps us to identify relationships between different elements of your code much better. And there's a paper on our website related to this graphical representation. It's called the Code Property Graph, excuse me, by our chief scientist, Fabian Yamaguchi. And that describes in detail more details about the code property graph. So once we've created the graphical representation, we start identifying and classifying data inside your application. So as Ethan pointed out, payment data, right? So we look at names of variables, and we essentially use text mining in NLP to identify these names and deem them as sensitive or not sensitive. And once we've identified these data elements, we start tracking the flow of data through the application. And so that really comprises the security DNA of the application, which is understanding the relationships to identify the source and sinks, understanding the sensitive data elements of your application and data flows related to those elements, and understanding the dependencies and frameworks that your application is using, so we can completely stitch the interactions together. The other question is, are there any plans to support .NET language? Great question. So we are actively, today we support Java. We are actively working on .NET, and we would love to work with you to solve for your use case, and that should be coming out soon, basically. The next question is, can other types of threat modeling be done for the OWASP categories? And the answer is yes. So basically, we looked at the violations group by OWASP widget, and as Etan pointed out, we have a policy out of the box that we provide, and it works for most of the applications. But if you want to fine tune that policy and define violations based on certain patterns specific to your application, you can do that. So then the categorization would be based on whatever patterns you define, and that can be done through policy. The other questions are, what about Python and Node.js? So again, great question on languages, because especially being in product, I love to understand what are the languages that are top choice of our customers. So besides Java and Node.js, Java and .NET, I'd love to take your input back on Python and Node.js. Basically, that would be later in this year. There's one more question on Python. So like I said, Python and Node.js would be in the second half of this year. There's a question on code analysis. How long does code analysis take? Will it slow down my build process? I think, Etan, this might be a great question for you to take.
Yeah. So obviously we're very cognizant of the fact that if we expect ShiftLeft to be integrated into a continuous CI/CD process, that it can't be too slow. So the code analysis should complete within seconds, and then the actual telemetry that you would see on the dashboard would probably appear within minutes. And of course, that's the code analysis side. So there's also the runtime component, and that's much more fast. So if a violation was seen at runtime, like a leak occurrence, that would be generated within seconds as well. So that's pretty exciting because from my experience, a lot of the legacy code analyzers that we've looked at, they are so slow to run the analysis that they're frequently left out of that continuous process. So they might be run, maybe once a month or even less, maybe once a quarter.
Great, thanks. The next question is, how can you prevent false positives? Again, I think our approach here is being able to analyze your application to understand the specific attack surface of that application or microservice, and being able to feed that information into the agent. And then being able to see what of these are actually manifesting at runtime, and being able to feed that back into the development. And so this whole approach makes it a lot more deterministic and reduces the false positives. And that's how we are able to achieve a much more precision in our product. So there's a question on code property graph will also include log analysis at any point.
I could try to answer this. So this is actually a tough question for me to interpret, but I'll do my best. The code property graph is you can think of that as the analysis stage that is analyzing the static code. But it's analyzing it in such a way that it needs to understand the logic flow and the data flow within an application as implied by the source code. So that graph is what's used to then figure out what vulnerabilities can we see in that flow, or what data leaks are happening, and we'll catalog the sensitive data based on the actual variable names in the code. Now, log analysis, I guess my interpretation of log analysis is more on the runtime side, where you'd feed your web logs over to something like Splunk and then set up certain filters so that you could detect and alert on incidents that way. So the code property graph, just as a piece of technology, is fairly removed from runtime. Now, on the runtime side, I could interpret this as, hey, would you be monitoring log data to augment the code property graph or something like that? So I think my answer to that is it's not on our roadmap at the moment, because we feel that when analyzing logs, you can see threats, but it's not quite as accurate as looking inside the code itself, which is really the core philosophy of this solution. However, we do know that if a violation was detected in code, and we see evidence that that violation is being leveraged at runtime by an attacker, then of course someone will also want to know who is doing this, and they want to get log data about to do forensics on like what has happened and what's the damage done. So it's possible long term we might do that, but it's not a short-term goal of ours.
So the next question is, how does ShiftLeft understand what is sensitive versus what is not sensitive? So basically what we do is we look at the names of the data, look at the names of the variables in your code, and based on those names, we classify them into various categories or dictionaries that we have, right? As an example, if you're for, let's say, a banking application or any other application, say you're using the variable name cc_num. So once we see cc_num, we mark it as sensitive. We basically look at the names, but we don't look at data values. So just to clarify that. And once we've identified that, we classify it, and we categorize it as sensitive or not sensitive. So the next question is, does the micro agent communicate with your backend? What type of traffic is this, and how big is it?
Yeah, so I can answer that question. So the micro, I'm not sure how many of you are familiar with APM agents or application performing monitoring agents. So it's a very similar technology in terms of, while those are not really security oriented, the way that they instrument the application and then the way they transmit data back to the cloud is very similar. So in other words, yes, so the micro agent is watching the entrances and exits of the application and monitoring calls on that in runtime, and it will send metrics back to our cloud. So those metrics don't contain much. They mostly contain identifiers for what those entrances and exits are, and then they contain calls per minute, and for the most part, the joining of that information with the real names of triggers and data destinations and so forth happens inside of our cloud, which also has the insights pulled from that code property graph. So it's fairly lightweight. The overhead should be actually much, much less than a typical APM agent for reasons I may not need to get into right now.
Yeah, just to add to that, basically we are aggregating metrics when we're sending that back to our backend. So in terms of network bandwidth that you need for this agent is not, it doesn't add to that network bandwidth.
Not significantly.
Yes. Great. So we've taken, taken all the questions that we had. Thank you, everyone, for joining and for being here with us. Look forward to talking to you guys again. Thank you.
All right. Thank you, everybody.